Okay, let's start. Last time we spoke about the autoregressive process of order one, which we call it a Markov process. We talk about Markov process. Then we try to calculate the autocovariances and then autocorrelation functions. And then later I gave you the exercise to do, which I hope you have done it. Then today we're going to do the autoregressive of order 2 or second order autoregressive process. So this is lecture number 10, I suppose. Okay. Lecture 10. And you are going to speak about autoregressive of order 2. AR2. So, how do you define autoregressive of order 2? So, a process, okay, xt is said to be second order autoregressive sorry, autoregressive or autoregressive of order 2, okay, provided xt is equal to phi1 xt minus 1 plus phi2 xt minus 2 plus zt. And zt, you know that it's a white noise. Okay, zt is a white noise, and phi 1 and 2, let me say phi I, where I is ranging from 1 and 2, are real valued constant.
Say
Eh?
on the autoregressive or that one is xt is equals to psi 1
Oh,
xt plus 1 plus psi 2 xt minus 2 plus zt.
yes.
All right.
Okay, constant. So a process xt is said to be second order autoregressive or autoregressive of order 2 if xt is equal to phi 1 xt minus 1 plus phi 2 xt minus 2 plus zt, where zt is a white noise and phi 1 and 2 are real valued constant. So this is how you define the autoregressive of order 2 process. So now, the autoregressive of order 2 is always invertible, but it's not always stationary or casual. So we have to find the conditions of stationarity or the conditions of causality. So we have got 3 conditions that we can use in order to check whether the process xt is stationary or not. So those conditions are, let me just go to the second page. I hope you are done. Can I go to the second one?
Yes.
Okay. So we call it stationary or casual conditions. Okay, stationary or casual conditions. Condition number 1, phi 1 plus phi 2 must be always less than 1. That is condition number 1. Number 2, phi 2 minus phi 1 must always be less than 1. That is condition number 2. Condition number 3, phi 2 absolute
Phi 2
value.
minus phi 1.
Oh, yes, thank you. So the third condition, the absolute value of phi 2 must always be less than 1. So those are the 3 conditions that we have to use when we want to check if the process xt, especially in this case, is the autoregressive of order 2. To check whether the condition of autoregressive of order 2 are fulfilled, we have to use those ones. So all these 3 conditions must be fulfilled or must hold for the process xt to be stationary or casual. If one fails, so the process is not what? It's not stationary. All of them must be fulfilled. Okay. So if you don't want to use this condition, you can use this one. So you have to write your process in backshift operator. Then you find the roots. So the process xt, which is the autoregressive of order 2, to be stationary or casual, the roots you know what is the roots? The roots are factors. You can call them roots or factors. The roots of 1 minus phi 1 b minus phi 2 b squared, which is equal to 0, must all be outside the unit circle. Are we together? The process xt, which is the autoregressive of order 2, to be stationary or casual, the roots or the factors of 1 minus phi 1b minus phi 2b squared, which is equivalent to 0, must be all outside the unit circle. Okay. I think it's clear. You can choose between the two, whether you want to use the conditions there up there, or you just want to use number 2, method number 2, where you have to write your process in backshift operator, then you equate it to 0, you find the roots or factors. because this one is a parabola. So you're going to have two factors or two roots. B will be equal to something or B equal to something. Therefore, all those two roots or factors must be outside a unit circle. If one is inside, another one is outside. So the process is not casual or it's not stationary. If one is on the circle, another one is outside. It's not stationary or casual. Both of them must be outside a unit circle for the process xt to be stationary or casual. I think it's clear. So now, if you recall on the Markov process is the autoregressive of order 1 process. If you recall in that process, we calculated the autocorrelation functions. But after calculating the autocorrelation functions, before calculating the autocorrelation functions, we calculated the autocovariance functions. So in other words, to calculate the autocorrelation function, you have to first to calculate the autocovariances. So which is a time delaying anyway. So but anyway, there is another method that you can use to calculate the autocorrelation functions without going via the autocovariance functions. So in other words, you have a process, you just want to calculate the autocorrelation function, you go straight to the autocorrelation functions without calculating the autocovariances. Because remember, initially we calculated the autocovariances, then you have to calculate the autocorrelation functions. So, but this time there is a method that you can use to just go to the process and then you calculate the autocorrelation functions without going via the autocovariances. And that method is called Yule-Walker equations method. The method that you can use to just calculate the autocorrelation functions without calculating the autocovariance first, we call it the Yule-Walker equations method. So this is the method that I just want to introduce for you. Yule-Walker equations method. Okay. Yule-Walker equations method. So in other words, you are going to have equations there that will help you to calculate the autocorrelations without calculating the autocovariances. So now let's go to those equations now. Let's say you have got two roots. You can call it two roots or two factors. Let's say you have two roots. Okay? Call it two roots or two factors. For argument's sake, let's say you have got alpha 1 and alpha 2. Those are the two roots or two factors. So the equation that you can use to calculate the autocorrelation function, if you have got two roots, is this one. Root k equal to a alpha 1 to the power k plus b alpha 2 to the power k. So this is the equation that can lead you to calculate the autocorrelation functions. In other words, you can let your k to be equal to 0 to get row 0. You let your k equal to 1 to get row 1. You let your k equal to 2 to get row 2, and so on. However, you are supposed to calculate the unknown values there. They are constant value there. There are these values here. You have to calculate them and find the answers for that. Then from there, you can substitute alpha 1, alpha 2, you're going to calculate it as well. Then k is where you substitute k by 0, 1, 2, and so on to get those autocorrelation functions at like 0, 1, 2, and so on. So this is the first equation. It's when you have got two different roots, alpha 1 and alpha 2. So the equation that you can use is alpha k, is rho k equal to a alpha 1 to the power k plus b alpha 2 to the power k. I think you understand that. So now, what about if you have got two equal roots? We call them double roots.
Sir,
Yes.
what did you say about A and B?
A and B are constant. You are going to calculate them. So I will show you how to calculate those A and B. But this is the equation that you are going to use to find the autocorrelation function. B in this case is constant, but you have to calculate them to find the exact values.
So, sir, we are also going to calculate alpha 1 and alpha 2.
Yes, that's true.
Okay.
But if you have A and B and alpha 1 and alpha 2, so it's a matter of substituting k by 0 to get row 0, k by 1 to get row 1, and so on. So, but anyway, don't worry about that. You will understand later.
All right.
So for double roots or same roots or same factors, in other words, alpha 1 is equal to alpha 2, isn't it? If alpha 1 is equal to alpha 2, the equation that you can use is rho k equal to a times k plus b, close brackets, alpha to the power k. So this is the equation that you can use if you have got equal roots or double roots.
So two roots and double roots are not the same thing.
There's two roots which are different. In other words, two roots we are referring to the roots that are different. In other words, alpha 1 is different from alpha 2. Double roots or same roots is when alpha 1 is equal to alpha 2.
All right.
Sir, is it rho k equals to AK plus B, or is it A plus B?
AK plus B, then close the brackets, alpha to the power k.
Right.
Okay.
Oh,
So
fine.
now let's go to come again.
Is it K or A K subscript?
It's A times K. It's A
Oh,
K. A times K.
okay, thank you.
Okay.
So, sir, what are we going to substitute there on K?
K can be 0, 1, 2, 3, and so on. Are we together? Can I continue?
Yes.
So let's go to another equation now. We call it, it's when you have complex roots. Complex roots. For those who are doing mathematics, they are dealing with complex numbers. Okay. So complex root is when your root contains I. For example, if you have got the square root of a minus sign, so the value is going to be I there because of a minus square root. So in mathematics, we call it complex roots or imaginary numbers or imaginary roots. Okay. So if you have that case of factors that are complex, you use this type of equation. Rho k equal to r double k cos k times theta plus I sin k times theta. Then you close the brackets. So this is the equation when you have got the imaginary roots. Your roots contain i's or vectors that contains i's. So you use rho k equal to r to the power k times cos k theta plus I times sin k theta. So where in this case, where r represent the radius, isn't it, of the circle, which is defined by x squared plus y squared square root. So to calculate the radius r, you have to use this formula. R equal to the square root of x squared plus y squared. Okay? And theta is an angle. Theta is an angle which is defined by arctan y over x, close brackets. But I think for the complex roots, this one we won't do it. It's going to be very complicated for you. Let's take it out. So we are going to deal with the real numbers there. So complex roots, I won't ask questions related to that. So are we together? Okay, let's quickly go to the autoregressive of order 2 process so that we can apply those type of equations, or one of those type of
Sir.
equations that are there.
Sir,
Yes.
you said you won't ask us what?
The third one, the third autocorrelation equation, the one that contains the complex roots.
Okay.
So we'll be dealing with the real numbers. The complex one, no. In other words, this one, let me just circle it so that you can see. This one. Don't bother, just introducing you so that you can know them. So there will be no question that's relate to this type of equation. Okay. Now let's go to the autoregressive of order 2. Then we try to calculate the autocorrelation function without calculating the autocovariances. In other words, without calculating gamma 0, gamma 1, gamma 2. We just go straight to row 0, row 1, row 3, and so on. Okay, let's go there. You are still ready? Okay. Now, you're done.
Yes.
Yeah, we're done.
Okay. There is somebody who didn't mute the mic there. Just mute your mic. It's making noise. Okay. Let me just go to the next page. Autoregressive of order 2. Xt is equal to phi 1 xt minus 1 phi 2 xt minus 2 plus zt. And zt is a white noise with mean 0 and variance sigma squared. Z. Now, the first step, you have to listen very, very carefully. The first step that we have to do is to change xt to be rho k, rho k, and then change rho xt minus 1 to be rho k minus 1, and so on. Okay, so xt, like I said, is going to be rho k by 1. Xt minus 1 will be what? Rho k minus 1. isn't it? Plus phi 2 rho k minus 2. When it comes to zk, zt, so you just ignore it or let it to be 0. Are we together? You change xt to be rho k, xt minus 1, rho k minus 1, xt minus 2 to be rho k minus 2. Zt is 0. Okay, that is the second step. The third step, you let rho k to be equal to alpha to the power k. Okay, so you are going to get what? Alpha to the power k equal to phi 1, alpha to the power k minus 1 plus phi 2, alpha to the power k minus 2. Are we together? After doing this, you divide by this one, alpha to the power k minus 2.
Sir,
Yes.
can you please go back to the previous page? I want to say something.
For the formulas. Yeah.
Okay, go back to that page. I thought maybe I missed something. Network kicked me out. So what are we doing on that page?
We are trying to calculate the autocorrelation functions now. So step number 1, we wrote the autoregressive of order 2 SCTs, xt equal to something. Then later, step number 2, you change xt to be rho k. Where there is xt, you put rho k. Where there is xt minus 1, you put rho k minus 1. Where there is xt minus 2, you put rho k minus 2. Then later, you
Why are we putting row?
we want to deal with the autocorrelation because rho represent the autocorrelation functions.
Okay.
Remember, we just want to calculate the autocorrelation functions without calculating the autocovariances. So that is why we're changing st to be rho k. Okay.
Okay, it makes sense.
Then from there, you let rho k to be equal to alpha to the power k. Why are we changing rho k to be alpha to the power k? We just want to find the roots now, or the factors. So this is what we wrote, rho alpha to the power k equal to phi 1, alpha to the power k minus 1 plus phi 2, alpha to the power k minus 2. Then later, you divide everything by alpha to the power k minus 2. K minus 2, because the one that represent the lowest power there. So everything you have to divide by alpha to the power k minus 2. Alpha to the power k minus 2. We're together there. Okay. Then the question is, what is alpha to the power k divided by alpha to the power k minus 2? You're going to get alpha squared, isn't it? Which is equal to what? Phi 1 alpha. Phi 1 alpha to the power k minus 1 divided by alpha to the power k minus 2 is phi 1 alpha. Okay. Plus phi 2 alpha to the power k minus 2 divided by alpha to the power k minus 2 is what? Phi 2. So this is your equation now. Then you take everything to the left hand side, then equate it to 0 to find what? The factors or the roots. So then you have what? Alpha squared minus phi 1 alpha minus phi 2 equal to 0. So now we just want to calculate the factors now, or the roots. So the question is, how do you find the factors or the roots using this parabola type of equation? You can tell me. How do you find the factors there? For alpha to the alpha squared minus phi 1 alpha.
Sir, before we come to that question, I want to understand this. We divided by alpha k minus 2 because you said it's the lowest what?
Yeah, it's the one that is having the lowest power.
Okay, it means we're even going to say to where there is k in the alpha, we put the power 2. Oh, never
Alpha to
mind,
the,
sir.
alpha to the power k divided by alpha to the power k minus 1 is alpha squared. You don't understand where alpha squared is coming from. Okay, it's like this if you don't understand, but it's simple arithmetic. We are having alpha to the power k, okay? You are dividing it by alpha to the power k times alpha to the power k squared. It's like that, eh?
Okay,
So when you
it's
divide this one, it's going to be alpha squared.
okay, thank you, sir. I understand now.
Okay. Then now I ask the question. We have a parabola. We just want to find the factors. How do we find the factors now in this case? In this the last step down there. How do you find the factors there? Obviously, you're going to have two roots or two factors.
Quadratic formula.
Yes, you use quadratic formula.
We use quadratic.
Yeah. In other words, alpha equal to what? You can tell me. If you still recall. Is it not alpha equal to minus b plus or minus
Minus
the square
b
root of b
plus
squared minus 4ac
b
divided
squared
by
minus
2a?
4ac divided by
Isn't it?
2a.
Yes, that is the one. So what is your a? It's 1. Your b is minus phi 1. Your c is minus phi 2, isn't it? So therefore, alpha will be equal to what? Phi 1 plus or minus the square root of b squared is phi 1 squared minus 4ac is going to be plus 4 phi 2, all divided by what? By 2. Did you get that?
So is it necessary to write the quadratic formula?
Is it necessary? Yes,
Yeah.
it's necessary because you want to find the roots. How are you going to find the roots now?
I can do it on a calculator, then substitute those ones.
Do you have alphas in the calculator there?
No.
So how are you going to find them using the
Oh.
calculator?
Ish.
Remember, this is not the real number.
All right.
This we're just using the so if you are using the real number, yes, of course we are going to use the calculator. But this time around, we can't use the calculator. Are we together? So now let's find
Okay.
alpha 1 and alpha 2. Go and tell me, alpha 1 equal to what? Phi 1 plus tell me
1 squared
phi1 squared plus 4 phi2. Okay.
2
Divided by 2, isn't it?
divided by
That is,
2.
yeah, that's alpha 1. Then alpha 2 will be equal to phi 1 minus, isn't it? The square root of phi 1 squared plus 4 alpha 2 divided by what? By 2. That is alpha 2. Now, the question is alpha 1 equal to alpha 2? No, they are not equal. So which type of formula are we going to use? If you still recall,
No.
which formula are we going to use? The first one is this one, yes. Okay. So now we are going to introduce rho k equal to a alpha 1 to the power k plus b alpha 2 to the power k. This is the formula that we're going to use. Let me just name the equation now. Let me say this is the equation number 1. This one, you see this one? This is equation number 1. Rho k equal to phi 1, rho k minus 1 plus phi 2, rho k minus 2. This is equation number 1. So then this one, let me call it equation number 2. Okay. And because if you check alpha 1 and alpha 2, they are too complicated, isn't it? They are too complicated. No, we can't just work it on in this way. So let's make it simpler.
Sir,
This one now, you can call it what?
sir,
Yes, pi 1.
which one is
Yes,
equation
no.
1?
Eh?
Which one is equation 1?
Okay, I'll show you equation 1. So this one is pi 2. So I make it simpler. The whole complicated thing is pi 1 for alpha 1 and pi 2 for alpha 2. Let me just go to the equation number 1, like we are saying. This is equation number 1. Rho k equal to phi 1, rho k minus 1 plus phi 2, rho k minus 2. That's equation number 1. Are we together?
Yes.
Then equation number 2 is this one. So then I simplified alpha 1. You see that? Now it's pi 1. Alpha 2 now is pi 2. Okay? We are going to use them. In other words, in question number 2, you can substitute by alpha 1 by what? By pi 1. Alpha 2 by what? By pi 2. So, but we are going to do that later. So now, let's say from equation number 2, you see equation number 2. So now, our main idea here, or our main focus, is to find the unknown values of A and B. It's to find unknown values here, A and B. It's to find A and B. Okay, we have already calculated alpha 1 and alpha 2. Okay, now we are left with what? A and B. So this step, the one that follows, we just want to play around so that we can find A and B. So anyway, you can just use any type of manipulation you can use to calculate A and B. But in this case, I just want to show you how can you find A and B. There are many ways. This is one of them. Okay, let's say from 2, equation number 2. Okay, equation number 2, you can see it. Let k be equal to 0. From equation number 2, we let k to be equal to 0. If k equal to 0 now, what are you going to get? Rho 0 equal to what? A plus B, isn't it? Because k equal to 0. From equation number 2, If you let k equal to 0, so you're going to have row 0 equal to a plus b. But you know from the properties of autocorrelated functions, row 0 is always equal to 1. So you can substitute row 0 by 1, and then you get what? And then you solve for a. Because remember, we just want to find the values of a and b. So therefore, in this regard, a will be equal to what? 1 minus b. Are we together? Could you say b minus 1 or 1 minus b? It doesn't matter. You are together, isn't it? Okay, that's it. But remember, still a is having unknown value b there. So you're still going to manipulate and find the real value there. Okay, now again, let's say from equation number 2 again, for the second time, we let k to be equal to 1. From equation number 2, we let k to be equal to 1. So what are you going to get? Row 1 equal to a alpha 1 plus b alpha 2. And remember, alpha 1 and alpha 2 are given there. So therefore, you can say alpha row 1 equal to a pi 1, okay, plus b pi 2. So you can just call it equation number 3. So we want to calculate a and b to find row 1 there. So to do that, we let equation number 1 to be equal to, let k to be equal to 1 from equation number 1, sorry. Let me just write it down. Because now we want to find the value of row k there. We just say from equation number 1. Okay. Equation number 1. Let k be equal to 1. Still remember equation number 1. This one. We let k to be equal to 1. If you let k to be equal to 1, so we are going to have row 1 equal to phi 1, row 0, plus phi 2, row minus 1. We're saying let k equal to 1 from equation number 1. Then you get what? Row 1 equal to row 0 and what? Phi 1 row 0, phi 1, phi 2, the plus phi 2 row minus 1. Is that true? It's correct.
Yes.
Okay. Now, from the properties of autocorrelation functions, row 0 is equal to 1, row of minus 1 is equal to row 1.
Sir.
Okay? Then, yes.
Sir.
Yes.
How are you, sir?
Come again.
How are you, sir?
How are you?
Yes.
This time around, you should have asked me at the beginning of the lecture.
I'm gonna wanna ask a question, sir.
You are delaying. You're taking our time. No,
No,
but
sir, I don't understand how you got to this part, sir.
which one?
The last one. This one you just wrote.
The last part.
Yeah.
We let, from equation number 1, we let k to be equal to 1.
Okay.
Question number 1 is this one. We let k to be
Yeah.
equal to 1. If k equal to 1, here is going to be row 1. This
Okay.
one is going to be row 0, and this one is going to be row minus 1. This is
Oh,
what
okay.
we.
Okay, I see that.
Okay, this is what we. Then we apply the properties of autocorrelation functions. So this implies that rho 1 is equal to phi 1, okay, plus phi 2 rho 1. You get that? Okay. So now we just want to solve for rho 1. Take the phi 2 rho 1 to the left. So you're going to get what? 1 minus phi 2 rho 1, which is equal to phi 1. Are we together? Therefore, rho 1 is equal to phi 1 over 1 minus phi 2. Are we still together? So rho 1 is equal to phi 1 divided by 1 minus phi 2. So now we calculated the autocorrelation functions at leg 1, okay, which is this one. So we can take it and substitute somewhere where? Here, at equation number 3.
Oh, sir, what happened to the negative sign?
Of which one?
There on phi 2 row negative 1. On the next step, you just said
Oh,
row 1 equals
I
to phi
said
1 plus.
we applied the properties of autocorrelation function. You still remember when I say rho k is always equal to rho of minus k. You still remember this? So therefore, rho 1 can also be equal to rho of minus 1.
Nah,
So
I don't remember that. You might have said it when I had like network problems or something.
Okay, no, it's fine. But anyway, let me just remind you. So rho 1
Oh,
is
no.
always
Okay.
equal to rho of minus 1. So that is why we change this one to be equal to rho 1 then.
Oh, no. All right. I understand now.
Okay. Any question before we proceed? So now we can substitute this one. Can I call it question number 4 or 5? I don't know. Yeah, question 4. Substitute equation 4 from equation number 3. Okay. Question 4 from question number 3. What do you get? Rho 1. You're going to get rho 1 equal to, is it A pi 1? B pi 2. Isn't it? But again, remember, we have already calculated the value of A. We said A is equal to 1 minus B, if you still remember here. This one, okay, this one. So now we know A. A is equal to 1 minus B. We can substitute here. Here, instead of B, oh, no, instead of A, let me just rewrite it again. Instead of A, you can put 1 minus B. So it's 1 minus B, isn't it? Pi 1 plus pi 2. Is it B pi 2? Like this, isn't it? And you can substitute again rho 1 by what? By this one. Okay. So therefore, let's substitute here as well. So here you're going to have phi 1 divided by 1 minus phi 2. Okay. Now, which is equivalent to what? Then you can open the brackets. You're going to have pi 1 minus B pi 1 plus B pi 2. So which is equivalent to what? Pi 1 plus B, open brackets, pi 2 minus pi 1. Are we still together? This one is pi 1. Okay, then we can write it nicely there. So in other words, phi 1 divided by 1 minus phi 2 is equal to pi 1 plus b, open brackets, pi 2 minus pi 1, close brackets. Then we just want to find the value of b there. Remember? We just want to find the value of b. So let me just go down. Phi 1 over 1 minus phi 2 minus pi 1 equal to,
Sir, can you please go back for a few seconds?
okay?
Oh, thanks.
Okay. Then b, open brackets, pi 2 minus pi 1. Okay. And therefore, b now will be equal to what? Pi 1 over 1 minus pi 2 minus pi 1 divided by pi 2 minus pi 1. So this is b. And then it's very complicated again. So we can just reduce it to be something else. This thing. Complicated. Don't want to work with complicated thing. So let me just call it psi 1. Because it's complicated. It's psi 1. Okay. Now this is your b. And remember, if you recall, a is equal to what? A. So I'm going to have a space. Remember, but a, if you remember, is equal to 1 minus b, isn't it? So now we have to substitute b by that one, by phi 1. Therefore, your a now will be equal to 1 minus phi 1, 1 minus phi 2 minus pi 1 over pi 2 minus pi 1. And again, this is complicated. Because it's complicated, this, the whole this of this, you can reduce it to
Sir,
say 2. Yes.
oh, we are substituting B on A, on equation, is it equation?
Hey, up there, I think we want me to go back so that we
Yeah,
can.
I had network problems. I just found you doing A, so.
Yeah, here. We said we substitute equation number 4 from 3, isn't it? Equation 4 is this one. From 3 is this one. Is this one. Then when you do that, you get this. At the end of the day, you're going to get this thing. After substituting, you're going to get this.
Yeah.
Okay. Then you work out until you arrive here. And then we realize that this thing is very complicated. Let us reduce it to something else. Then we call it psi 1. Okay.
Oh.
Okay. Then remember at the beginning we said that a is equal to 1 minus b. And b is the whole of this thing. So we substitute and get this. And we realize again, hey, it's too big. It's too complicated. Let it to be equal to psi 2. That's what we have done.
All right.
So in other words, A is equal to psi 2 and B is equal to psi 1. Then you can substitute from the original to get the autocorrelation functions now. Now we are done here. It's the matter of taking this back to the original. We substitute A and B from original autocorrelation function equation. That is the last step that is left for us.
Sir,
So, yes.
for A, why don't you just say y minus 31?
For A, why don't you say what?
1 minus 31.
1 minus? I can't get the last step, the last thing.
31, because we said beta is equals to 31.
Oh, so that means we just want to see that it must be related. If you say so, so that means side 2 now is going to be changed to be say something. It's the same thing. You can just write the way you want. It's just the matter of reducing this complex thing. You can just do anything you want there. As long as you are reducing this big complex thing there. Yeah, I understand what you're saying, because psi 1 is the same as the whole of this, okay? And the whole of this is there. So you can just say, okay, A is equal to 1 minus psi 1, which is the same as, it's going to take you back to what? The whole of that thing again is going to be equal to what? Psi 2. So we just want to write it nicely in the equation there without any complications. Are you done?
Yes.
Okay. Now let me just take you back there from the original autocorrelation. Yes, here. Actually, we want to, where is it? Yeah, this equation number 2. Okay, this is the original autocorrelation function equation. Okay, let me just write it like this here. So we just want to substitute from that one. Remember, this is the one. Okay. 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 So now, A now it's what? It's psi 2. Is it psi 2 or psi 1? It's psi 2, yes. Psi 2. Then alpha 1 is pi 1. Then to the power k. Okay. Then you say plus. B is psi 2, psi 1, sorry. Alpha 2 is pi 2 to the power k. So now rho k equal to this. Now you can say where k starting from 0, 1, 2, and so on. What does that mean? This is what we have been looking for, because they said calculate the autocorrelation functions. Let's say at leg 1 or leg 0 or leg 2 or leg 3. So now if you let k to be equal to 0, if k equal to 0, you're going to get rho 0. Okay, substitute there by 0. So you're going to get what? Psi 2 pi psi 2 plus psi 1. Psi 2 plus psi 1. If k equal to 0, isn't it? Psi 2 plus psi 1. That is rho 0 there. But if there were numbers, real numbers, you have to find it to be equal to 1. There's no way. You have to get 1. Otherwise, if you can't get 1, so you made a mistake somewhere there. So in our case, we are not getting 1 because it's not the real numbers. Are we together? When you are using the real numbers, you must make sure that your rho 0 equal to 1. Then find rho 1. Rho 1 actually is supposed to be, let me write it nicely. So k equal to 1. So you'll find that rho 1 must be equal to this one. We have already calculated row 1 here, if you still remember. Row 1 is equal to this one. Phi 1 divided by 1 minus phi 2. So even here, you have to find phi 1 divided by 1 minus phi 2. If you substitute k by 1 here. So because in our case, we just say, hey, we're dealing with the complex thing. Let that complex thing to be equal to something. So you can't get it now here. But you're supposed to get this thing if you substitute k by 1 from the original equation. Are we together? Okay. To understand it better, let's just go to the real numbers now. Unless if you have any question before we go there.
Sir, can you please explain the row K part?
The row
Row,
K.
yes.
Which one? The second part.
The second part.
I'm saying what we have been doing all along from here. From here. Yeah, from here, from equation number 1. These steps, we just want to calculate, to find the autocorrelation function equation. Okay. We wanted somebody's making noise there. Can you please mute your mic?
Becky,
Okay, thank you very much. So what we have been doing, we wanted to reach at this point. This point, we call it the autocorrelation function equation. This is the equation that can give you all autocorrelation function. It's either row 0, row 1, row 2, row 3, and so on. You get them from this equation. Okay. So if you let k to be equal to 0, obvious row 0 equal to 1. So you are supposed to get 1. But in our exercise here, we didn't get 1 just because it was complex and it's not a real number. But if you are dealing with a real number, you are supposed to get row 0 to be equal to 1 and row 1 to be equal to phi 1 over 1 minus phi 2. So in short, row k, this equation row k here, is for all autocorrelation functions. So that is why if the question says use Yule Walker to calculate the autocorrelation functions, so you're supposed to get a point where you have an equation like this, where when you want row 0, you are going to get it. You want row 1, you are going to get it. Row 2, row 3, and so on, you are going to get it. I don't know whether I'm clear.
Yeah, I understand. But the one here K0 is equals to row 0 is equals to alpha 2. Is it psi 2?
Hey, psi 2 plus psi 1. You know why? It's just
What?
because we are not dealing with the raw the real numbers. Remember here we just let to be equal to psi 1, here we let to be equal to psi 2. So it's complicated. But we were supposed to get 1 there if you substitute k by 0. But because now here it's not a real number, it's going to be complicated to reach at this point to find 1. In real numbers, make sure that when you substitute 0, you're going to get 1. Otherwise, you made a mistake somewhere.
All right.
Yes. Now, let's quickly go to the real number now. Let's take one example and try to apply this. For those who are
Sir,
doing the... Yes.
would I be wrong if I would just say row 0 equals to 1?
You are not wrong. This is the property, isn't it, for autocorrelation function. However, if you substitute there from the equation by 0 and you don't get 1, you must know that your equation is wrong.
Okay, sir.
Yes. Okay, let's take this one now and see. Example. It's example 3.9.2 from the lecture notes, page 33. Is the autoregressive of order 2, AR2, defined by xt equal to minus xt minus 1 minus quarter xt minus 2 plus zt. And remember, zt is a white noise. Zt is a white noise, which means 0 and sigma squared z. So this is the process. We just want to find what? Find ACF for xt. Let's say using Yule Walker equation. See now, Yule Walker equation. Okay, before you find ACF, remember I told you you can't find ACF if your process is not stationary. You have to make it to be stationary first. It's then that you can find ACF if it's not stationary. So I'm asking you, is the process stationary or not? You can quickly identify that. Just find it out, whether it's stationary or not, so that you can proceed. I'm giving you 2 minutes to do that.
Yes, I think it's stationary, sir.
That's true. Yes, it's stationary. So now we can find the autocorrelation function. Let's start. We're using Yule Walker. Where do we start? You change xt to be
What
rho
are
k.
we saying is stationary?
Why? Oh, you want those who said it's stationary to explain why? Those who are saying it's stationary, may you please explain?
I think it's because
Okay.
the absolute value of what's that thing? Phi 2 is less than 1.
Uh-huh. No, you
And
don't take
again,
only one condition. All conditions
yeah.
must be fulfilled.
Oh yeah, and because phi 2 minus phi 1 is less than 1, and phi 1
Okay.
plus what do you call it? Phi 2 is less than 1.
Okay, that's true. I think you got the answer. Okay, now let's quickly go to that one before the time is up. So xt now is going to be rho k, isn't it? Which is equal to minus rho k minus 1 over 4 rho k minus 2, isn't it? That's step number 2. Step number 3, you let rho k to be equal to alpha to the power k, isn't it? Let rho k equal to alpha to the power k. So you're going to get what? Alpha to the power k equal to minus alpha to the power k minus 1 minus 1 over 4 alpha to the power k minus 2. Are we there? Then divide by the highest, by the slowest power. Okay, so we are going to divide it by what? Alpha to the power k minus 2, alpha to the power k minus 2, alpha to the power k minus 2 there. Then what is the answer now? What is the equation? Now, the equation is what? Alpha squared, isn't it? Plus alpha plus 1 over 4 equal to 0. Is it true?
Yes, sir.
Yes, true. Then you can just write it in this way so that it can be more simpler. Can I go to another page? 4 alpha squared plus 4 alpha plus 1 equal to 0. Isn't it? Yes. Okay. Then you find the roots or the factors. So it's 2 alpha plus 1, 2 alpha plus 1 equal to 0, isn't it? So alpha 1 equal to minus half, which is equal to alpha 2. What do you do? Which equation are you going to use? So you're going to use this one, okay, equal to A times K plus B multiplied by what? Alpha to the power K. Okay, so now this one is going to be equation number 2. Knowing very well that rho K equal to something is equation number 1. This one is equation number 1. Hey, what is happening? Yes, this is question number 2. When you are here now, what do you do? You, from equation number 2, you let K to be equal to 0, isn't it? Say from equation number 2, let your K to be equal to 0. If K equal to 0 now, what do you get? Rho 0 equal to it's equal to B, isn't it? If K is 0, therefore B equal to 1. Are we together?
Yes,
Yes,
sir.
sir.
Okay. Then again from equation number 2, you let K to be equal to 1. If K equal to 1, you go to rho 1, A plus B alpha to the power 1. But you can substitute by what? By alpha by a minus half and so on, and B by 1. But let's find rho 1 first. And how do we find rho 1? You find it from equation number 1. Okay. By letting what? K to be equal to 1. From equation number 1 up there, K equal to 1. So it's going to be rho 0, rho 0, rho 1. So rho 0, rho 0, and what? Rho minus 1 or 1. Rho minus 1.
Sir,
Yes.
on row 1, won't it be A alpha plus B alpha?
A alpha plus B alpha.
Yeah. Isn't the alpha multiplying both the A plus B inside the bracket?
Oh, yes. Here, ne? A alpha. Oh, no. I think we, oh, okay. Yes, that's true. Yeah, it's like this. So what do you say?
Oh
Because it's
yeah,
one.
like that.
Yeah, that's true. You're right. Because it's multiplying everything.
Say,
This one. Yeah. Yeah.
Yeah. Now K it's 1. Why do
um,
we have row from equation 1? We let K to be 1. Then why do we have
Yeah.
that? Isn't supposed to
Mm,
be row 1?
One. Oh, yeah. Just because you're right. Yes. That's very nice if you can be able to see the mistake. Yeah, ne?
Yes.
Right. Yes. Thank you very much. We're together. Here is one. Yes. So what do you say? It's okay.
Yes.
Okay. Now, from here, the last step there, so you can play around until you get row 1. So let's play around with that one. So if you take that one, okay, you're going to have. Let me just do it here. So if you take that one to the other side, so it's 5/4, I think. Row 1 equal to -1. Is it true? Is it 5/4 row 1 equal to -1? Yes. I think it's true. Therefore, row 1, don't want to go to the next page because it's the one that is confusing us. Therefore, row 1 equal to -4/5. Remember, I told you that the autocorrelation functions, the values of autocorrelation functions are like the values of the probability. It must not be greater than 1. Okay? That is why here row 1 now is -4/5. So it's not greater than. Because sometimes you can find that somebody got row 1 to be equal to 5/4, which is 1 comma something. It's wrong. It can't be greater than 1 autocorrelation functions values. So the question is, row 1, is it equal to -4/5? You're still there? Or I'm alone?
yes, sir.
So I'm asking, is it the correct
It's
value?
-4/5, yes.
Yeah, okay, it's fine. Let me just say question number 3, this one. So you can substitute this one from where? Okay,
Say I'm lost.
you're lost. Where?
From equation 1, let K is equals to 1. Yeah, now
Oh, from equation number 1, you are letting K to be equal to 1. Here, equation number 1 is here. This is equation number 1. We are letting K to be equal to 1. If you let K to be equal to 1, here you're going to get what? Row 1, sorry. Isn't it? Which is equal to, here you let K to be equal to 1, you're going to get minus row 0. Okay? Let K to be equal to 1, you're going to get row -1. Are we together? So
yeah.
this is what we get. This is what we got there. Okay? From there, but we know that from the properties of autocorrelation function, this one is the same as row 1. Then you take it to the left. When you take it to the left, so you're going to have row 1 plus 1/4 row 1, which is equal to -1, because row 0 is always equal to 1, isn't it? And there is a minus there. That is why we're using this one. So this one is the same as like 4/4. So when you add this together, it's 5/4 row 1 equal to -1. This is what we
Oh,
get here. This is the one.
all right.
Then later, so row 1 equal to -4/5. This is where we are. So now, We substitute equation number 3 from equation. Oh, this one's supposed to be equation.
From the one
Something.
above.
Yeah. Yeah, we are substituting equation number 3 here on this one. Equation 2.1. Yes, substitute equation 3. Substitute equation 3 from 2.1. Okay. When you substitute it there, what did you get? Minus 4 over 5. Minus 4 over 5. It's equal to what? If you check A, we don't have it here, but B we have. This is the B. Alpha we have is minus what? Half. So we can say A plus 1. A plus 1 minus half. Isn't it? Isn't it? So then I like this red one because it's visible. Then you multiply by minus 2 over 1. Minus 2 over 1. Then you get what? 8 over 5 equal to A plus 1. Isn't it? Then you subtract 1 there. You're going to get A equal to, is it 3 over 5? Yes, 3 over 5. Are we still together?
Yes,
So
sir.
you have
Okay.
A.
Yes, sir.
Yeah.
Yes.
Yes. It's correct, isn't
Okay.
it?
Yeah. I
Yeah,
just
it's
want
correct.
clarity here. Where we
Yes.
substitute 3 from 2.1. What is our 2.1 conjugate?
Here.
Can you
Here.
go back?
This one. It's here.
Oh, okay.
So you have A and B. Then you take everything. So you take everything to equation number 2. Then you substitute everything here. Then you get your equation. Okay. So now you're going to get what? Our time is up. Okay. Our time now is up. Okay. So now row K is equal to A is what? 3 over 5. K plus B, which is 1, multiplied by what? By alpha, which is what? Minus half. Okay, it's multiplied because so this is the occasion for 0, 1, 2, and so on. Okay, now we are done. This is what we have been looking for. So let's verify. If K equal to 0, so row 0 equal to what? You substitute K by what? A 0. The whole of this is 0.
Sir, sir,
Hmm?
it's
What is happening?
alpha exponent k, like negative 1 over 2k.
Oh yeah, there is a key. Thank you. That is why now I'm confused. Why is it not giving us 1? Okay, yeah, this is the equation now. Yeah, thank you very much for that. So if you substitute k by 0, you are going to get what? Here, this part is going to give you 0. This one 1. Then you left with 1. So it's 1. You get now. If you check row 1 there, row 1 is equal to what? Row 1 is equal to minus 4 over 5. When you substitute here k by 1, you must get minus 4 over 5. Okay, let's do that. Substitute this one by 1. So it's going to be 3 over 5 plus 1 minus half, isn't it? So this one is 5 over 5 is 8 over 5, isn't it? Then multiply by minus half. So this one cancels this one is 4. So the answer is minus 4 over 5. Is it true? Row 1, is it minus 4 over 5? Yes, it's minus 4 over 5. So you see now, it's working. So let's stop here. Our time is gone. Any question?
Sir,
Mm.
sir,
Yes, I'm listening.
Akira, you said for the process to be stationary, it
Yes,
must satisfy all the three conditions, right?
definitely.
Oh, can you hear me, sir?
Yes, I can hear you. Just speak because others now. Mm.
Sir, I still here.
Yes, I'm around. The problem is that the time is up and people
Okay,
now
I'm asking Akira, you said for the process to be stationary, it must
yeah.
satisfy all the three conditions. So what if
Yes.
it doesn't satisfy all of them? Is it ever possible?
Yes, it's possible.
And if it doesn't satisfy all of them, we say it's not stationary.
It's not stationary, definitely.
Okay, thank you, sir.
Mm. Okay. Now let's stop here.